Okay, this is Karen O'Brien, and we are doing the final webinar in this series of multiple domain exchange. First, we set up a project and we split it into that one here. We set this project up and we split it into two domains, the north domain feeding the south domain. And then I wanted to expand that and show how to split a project into more than two domains. That was week 2. And now we are taking those projects and applying the channel connection to them as well. That's what we'll be doing today. So if you want to see those videos, these two are available, and this one will be available after after today's video is done processing. So typically if you hit the registration button and you fill it in again, it'll take you straight to the video if the webinar is finished. So a quick recap from part 2 was that I took part 2 across these two different profiles. Let me show you. I'm going to select the southeast. So this was the original domain split was just north to south. So these two domains were still into single domain. Just did that to show you the simplest way to set up that domain or that domain exchange process. But then I also wanted to show you how to set up a channel that crosses a domain. So I went ahead and split these two up. But just to show you, just to remind you, if you split your domain into 2 or more, the way that you do that is with this boundary control right here. So you make a polygon across this boundary and make sure that it kind of like feeds, in this case, it feeds this domain. And then there's an alternate one for the southwest that would feed this domain. And then the rest of this area down here does not cross the boundary. So the water flows north to south. Maybe we can pull that up. The water flows mostly north to south, and then down, once it gets down here into the valley, it starts to also flow toward the west. Okay. All right, now, again, just a couple of disclaimers because this is kind of a silly project in that, meaning that I split it up in a way that I wouldn't normally do in real life, but I wanted to show you a couple of different things. So the way that I split this is maybe not like typically if I were going to split this, I would just split it north and south and I wouldn't do these two down here. And there are, if you were to set the full domain to 20 by 20 grid, there's only like 1.6 million cells. So I would, in reality, I wouldn't even need to split this. It's perfect size for Flow-2D. But just to show you the process and make sure that the model runs relatively quickly, we're using these smaller grids. This cell size up here, I set to 60, and these two down here, I set to 20. So I set this originally was like 50 up here, and then I realized when I went to overlap them that they didn't align very well. So I went ahead and modified this top one to 60 so that the downstream grid would fit into the upstream grid. It would align perfectly. And you can see that in the first video. So these are just a couple of recaps of things that, to help you recap this. You can have, this could be all 20 as well if you wanted to do it that way, but I do try to make them to where they would align correctly so that the smaller cell size would fit perfectly inside the larger cell size. And of course, it is important when you're doing your overlap. Let me turn a couple of things off here so we can just see, is to overlap one of the downstream cells so that you don't have, like if I were to overlap this by one of the upstream cells, which are 60 by 60, then I would have 3 deep inflow nodes on my downstream model. I only want one line of inflow nodes on my downstream model. It captures the whole volume, so that all of the volume and from the hydrograph that is captured by this outflow node is distributed to its 3 domain connecting neighbors or domain connecting inflow nodes. They become inflow nodes for the downstream side, which you can see those here. You can see them here. And so 3 of these would represent the single outflow node from upstream. Okay. So that's kind of the key to splitting up the domains. And then you saw in the video how I overlapped them slightly by just moving the domain using the advanced digitizing tools. Just gonna click on this right here just so that you can see these advanced digitizing toolbox. This one is a move. You can split them. You can merge them to get, you can stitch two of them together. So there's a lot of great tools here for computational domain modification. Very simple and easy to use. And I show you how to do all of that in the first two videos. So let's focus now on the channel. So once I split out the southwest and southeast domain, I then added the channel. Whoops, I didn't mean to hit edit. I meant to hit zoom to layer. And then I am done with editing these. I'm just gonna turn off the editor on those and save all those edits. I had to do some minor modifications to these cross section, or to this left and right bank, so that the left and right bank were far enough apart so that the model didn't give me an error stating that my channel banks were too close together. Just put the channel in upstream to downstream, and originally I did, let me zoom to this one now real quick. I want to zoom to, let's just do this. Let's zoom to this one, and then I'll kind of zoom in on the part we want to see. So originally I had this entire south domain, and that's what I used to build the channel. I just took the entire south domain, built the channel all the way across it, and then I split it at a single cross section. So this cross section is 27 right here. That's, whoops, let me do this so it will highlight it. Okay, this is cross section number 27, and it's the exact same cross section in the downstream. So if I go to cross section 27, you can see that it's the first cross section. And it will just zoom into it, and they are aligned in the exact same cross section. And then the overlap in this is just this grid, this line of grid elements right here just overlaps. Let me turn the grid on so you can see it. Just overlaps this line of grid elements here. Let me turn this image off real quick. This right here. And what happens is that these outflow nodes fill the southwest domain. Along here, they become inflow nodes for the southwest domain. And these, let's see, and then for the channel, I take the hydrograph from the channel at cross section, at the very last cross section, and that I develop that into a hydrograph for the channel in the downstream model. So a couple of things to note: you don't really maintain that momentum and velocity as you're crossing this boundary with Flow-2D. Typically it's okay, because what we're doing is we're starting at the beginning of the simulation, so there might just be a base flow in there. In this channel, there's probably the minimum discharge, or the average annual discharge for this channel is around 7,000 cubic feet per second. So if you wanted to do a baseline channel flow in this model, you could just set that up with a baseline flow that fills the channel, or you could do a channel depth and a baseline flow. So an initial depth in your channel and a baseline flow. But in this case, I just did the baseline flow, let it fill the channel, and then that is what fills this, or that running from upstream to downstream at this boundary is what feeds the downstream model. So let's see. Let me see what else we wanted to talk about. So after I ran, when I ran the north domain, it creates these inflow nodes for the southeast domain, and it does a bunch of inflow nodes for the southwest domain. Those can go into individual data files. I'll show you how that sets up in the run folder. So this is my north 60-foot grid with 2 domains, and it has the CAD points DS1 and the CAD points DS2. So CAD points DS1 was the east, CAD points DS2 was the west. And I chose that because if you look at these guys right here, hold on a second, we'll go southeast. This is O1, which goes with DS1, okay? So O1 node, the O1 outflow nodes, which are right here, are aligned with the downstream the downstream domain number 1. And the O2 nodes that are here are aligned with the downstream domain number 2. Okay, so that's why we get DS1 and DS2. And then when you run the model, you get inflow 1 and inflow 2. So then you can use these two inflow nodes in the downstream model to set those up. Now, unfortunately, this one's kind of ridiculously complicated because of this boundary right here. So you got to be a little bit careful with it. And then that's why I tell you, don't try to meld or mesh a model on two connecting domains. Just use one, but then I wouldn't be able to show you these other processes. So that's why I did it this way. Okay, so here is our southeast. That one's kind of the important one, right? So I take the I take the inflow hydrograph from the north domain that crosses into the south domain. It just becomes inflow.dat. But since there is also a downstream connection right here, I also need this guy right here. This is the CAD points DS1 for this this domain, for the southwest domain. So that's why this becomes overly complicated. But in order to show you the process, it just makes sense to just kind of just be complicated for the sake of the lesson. So don't get confused by it. And then when you run this one, you get this inflow DS1, which is what processes the discharge across this boundary to feed the southwest domain. In addition to that, one thing that you don't get is what crosses through the channel. So if you want to get what crosses through the channel from these two domains, you have to set that up slightly differently. So in my inflow.dat file, you should see that. Hang on a second, I'm missing something here. Oh no, I know what I'm missing. I'm in the wrong folder. Sorry. Here we go. So when you get ready to set up your channel in your inflow, you also need to set up your base flow for your channel. So if your channel doesn't have any water in it, you don't need to set up a base flow. But if your channel has a base flow, then you need to make sure that water is, you will either do it with an inflow hydrograph like I did here, and I didn't set it to 7,000 cubic feet per second. I just set a base flow of 1,000 cubic feet per second, and it runs for the full 10 hours. But you want to set up the physical base flow of your system, not, this is just to show you the process. So this is a channel inflow node for my channel that's going to be crossing this boundary right here. I'm going to show it to you right now. Okay, that's this inflow node right here. And then that will fill the channel with the baseline flow. And then whatever rain and whatever inflow crosses into the channel will be added to that to pass the boundary down here. And we will take the hydrograph from this boundary down here to build that into the hydrograph for the next channel in the southwest domain. Okay, so let's take a quick look at that. So here is our outflow node for the southeast domain. Let's go ahead and grab that right here, outflow.dat, and you can see that we have an outflow hydrograph. That's these two right here, and we have our downstream domain that connects into the southwest model. That's O1. This CAD points DS1.dat is from the southwest domain. And then when you run it, you get this inflow ds1.dat, but it does not have any flow from the channel in it. So it only has the flow that crosses the domain. And you also have the high-chan.out, or you can get the inflow node, or you can get the hydrograph that goes down the channel from hydrog. So we'll take a quick look at our hydrog right now. We're going to look at the hydrog as the water and how it moves through this channel. So if you open hydrog and you plot your channel hydrographs, you can go all the way to the bottom, and you're going to see something here of importance. This is grid element 333. It's not going to have any discharge because it's an outflow node. This is grid element 702. We will take our hydrograph from this one. So if I click OK, and then I go downstream, whoops, sorry, I needed to go upstream. I messed that up. Here, let's try that again. Click OK, go upstream, and you see that this is your discharge for, your baseline was 1,000, so it takes about, looks like it's taking about 4 hours for the water to get to it. We had that baseline discharge of 1,000 cubic feet per second. And then this is whatever rains and drains into the channel in excess of that. And you can see a couple of things about this. One is that we haven't really quite drained the whole project yet. And we know that we need to run this for more than 10 hours. We know that this 10-hour simulation is just to, test the process. And what we do need is we need this hydrograph. So if we return to menu, we can print that to a text file, and it will just print it to a text file called 702. So that says that the ASCII file has been created, and now we can close hydrog. And if we come in here, we should see 702. And if we open that in Notepad, you'll see that we have the hydrograph right here from high-chan.out. And all we need to do is to convert this to a inflow hydrograph, which is super easy. You'll need an H right here. So if I hit the Alt button, I can use block mode, and I can put an H in there. And then this will need to be, let's see, it's not 702. That's not the correct grid element number, because we need the downstream grid element number. So we need to go get the channel.dat file from the Southwest model. You can see that right here, Southwest model chan.dat. We need this grid element number because that's the first grid element number. So I'm going to copy that back in here. This becomes C space 0, meaning that it's an inflow, not a diversion. 0 is inflow node, or so hydrograph is added to the system. 1 would be a diversion, meaning water would be taken away from the system. And then the grid element number, which is the channel, and of course C is for channel. And then you could take that into your downstream Southwest model. So we're going to leave this here right for a second. We'll just leave this here, or you can save it. I think I saved it as, when I did it before, I saved it as channel inflow.txt. Yeah, they're this exact same file. They're just spaced a little differently. It doesn't really matter how many spaces you use, because Flow2D will read all those spaces as one delimiter. Okay, so what we have now is we have the inflow from the northwest and the inflow from the southeast. We have to combine these into the total inflow for the southwest. So I would just take and copy. Well, let me show you. I only need one line for here, and that one is already here. And you don't need, this can be 0 because we're not running this in detailed graphics. We're just running this in text mode. So this can be 0. And then you can see that this starts from, let me control home up here. This one starts from up here, 72116. I also added my channel inflow hydrograph from the number 702 over here. And this is, the rest of these are F lines for the two crossings. So this is coming from the northwest. And then if you look here, I'm going to just copy this. I would copy all of this. So if I put this to my first F, beginning of the first F line, Control Shift End, will select everything to the end of the file, not including that first line, because we don't want this. We don't want that first line because it's already here. And then we just go Control End and you would paste it. But I've already done that, so I'm not going to do it. So instead, I will put this in my clipboard, Control F, and then go here. And you can see that that's about halfway down. If you look over here on this side, you can see that's about halfway down. So I just built this manually and put my channel in manually, and then this one is ready to go. Then I put that into the Southwest channel run, and it has the inflow.dat right here is from this guy. And the channel and everything else is ready to go because I processed it all, interpolated and all that, on its own. And then you just double click and run it, and it will read and process the project. Now this is a much simpler outflow condition because it only needs it needs that K line, meaning that this is a channel output, and it needs these guys just to get any water from ponding along the boundary, because there's no more exchange happening in this very last model. Okay, so let me see. Sorry, let me get to that one. So here is the Southwest model, and here is the downstream boundary condition for the Southwest model, which most of my water is leaving at this outflow node right here. And then this was just in case a little bit of extra water escaped into their rainfall, whatnot. That was the purpose of this this boundary condition here. And as you can see in this case, I took, let's see if the boundary condition is in here. I took this guy. Let's do this. That is your channel, and then this guy here is just a polygon along this boundary, and then the Flow-2D plugin will identify which of the nodes become the boundary. So you don't have to go in with like a polyline or dots or anything and try to set these up individually. You can set them up with a polygon. One of the things that I see a lot of people doing in Flow-2D, let me get back to the full domain real quick. One of the things I see a lot of people doing in Flow-2D is trying to make the entire boundary outflow nodes. Don't do that. Okay, that's just a waste of your time, a waste of processing time for both the engine and the plugin, and it's not realistic. You don't need a boundary where water isn't going to be crossing the boundary. You don't even want a boundary where water is going to be crossing the boundary because it changes your grid element elevation in some locations. So only want a boundary where water is going to be leaving the grid system, not for the whole project. And that's why I always run a model to see where the water is collecting along the boundary before I start to worry about where does my boundary condition go, or where does my boundary control go. And you can see here, I also did the same thing with these boundaries. I set them up here. Oops, let me zoom out a little bit so you can see. I set them up also with a polygon. So the polygon works with type 1, type 4, type 5, which is a time stage, and type 7, which is a time stage and a free floodplain. So it works with 4 different kinds of boundaries. It doesn't work for channels, and it doesn't work for, what is this one? Floodplain and channels. So you just can't use it for channels. You can't use a polygon for channels. You need a point for the channels. All right, so now that we have a little bit more information, let's start to map a little bit of this stuff. It shouldn't take very long to map some of these. So let's start by mapping the full domain. Okay, so I'm going to build a group called results. And I think I want to put it like maybe right here. I'm going to select that group, and I'm going to click the data manager, the data source manager, and add a mesh layer. So you can add a Flow-2D mesh layer. Sorry, I'm in the wrong domain here. Multiple domain runs. Let's go ahead and get the full. And just get the depfp.out. That's the one we want for this one. And click add. And it's just letting you know that it's because that data set didn't have a coordinate system, it's going to define the project coordinate system. And I'm going to go ahead and close that so that I can name this one full. Just want if you right click it and just hit the N key, that's rename. Okay. Going to do that a couple more times to get those other domains in here so that we can see them working. So the next one will be, let's see what we want next. I guess I can do this one next. And N, let's call this one 2 domain, north 2D for 2 domains. Let's call it 2 domains since 2D means more than one thing. And now we'll get the one from the southeast. That's this guy here. And remember, we did our run in this folder, so I'll grab it from here. Now this one you can bring in the 1D and the 2D mesh, but I think I'll just bring in the 1D or the 2D mesh because it should show you a little bit about what we need anyway. We'll see. Well, we probably don't have to go back and get it. Let's go ahead and click add. Let's see, is that actually working or do I need to click add? I think I need to click add. Nope, that should have worked. Oh, sorry, I was in the wrong spot. I'm gonna remove that one. Right click R is remove, right click N is rename. And this one is southeast. And then we'll grab the southwest. Okay, one more time. Okay, runs southwest. And again, we want the channel one and depfp.out. And then we click add. And this time we want the mesh 2D and add layers. And it should, there we go, perfect. Okay, and then this one is right click N, southwest. Okay, so I believe, those two don't have, unfortunately, these two didn't have time data. I must have turned that off. So we'll just be getting the maximums from those. That's just so you know. Okay, so let's start this with our full domain. And let's turn off like maybe some of these other layers. And let's turn that off. And I can't turn that off because it's selected in there. So let's see if I can style. I wonder, let's do this. I'm going to try to add the style, but I think what I have is like I actually have this style saved somewhere. So first of all, let's set this to flow depth. And so I thought I could load that style, but I always forget how to do it. Oh, because it's not there, it's here. And let's see, there is somewhere in here, you do have the opportunity to like load the whole style, which would be nice. Let me see. well, dang it, I can't remember how to do it. So let's just do it quick. Let's just quickly fix this. So depth 0.01 or 0.1, whatever, just something so that the whole map isn't covered in colors. Clip out of range values, set that to blues, change that to equal interval. 6 to 8 classes. Let's just keep it simple. We'll do 6. This will be 0.1, 0.5, 1. Let's see, that could be 5. And I think, yeah, and then this one is 5 to 16. And now what we need, because we can't see that yet, so what we need is to turn on the time. So again, we'll click this first and then this, so we can set it to the full range of time. And then you can start to see the water transitioning from north to south, or moving from north to south along your boundary, okay? And that very first one was what I used to help identify my boundary and where I wanted to create my boundary. And then the second one, north domain with 2, let's take this style. So I am going to copy the style from the full domain and paste it to this domain, so that you can now see, I'll turn this off so you can now see that this one, you can also see this domain. And if you remember, I had these two, my boundaries were right here, so you can watch the flow build up along that downstream boundary. Okay. And that was what I used to feed the 2 downstream boundaries. So then we started with this one. The inflow came from here, and I gave it a baseline from right here. So let's grab the style from here, copy style, paste style. And now you can see the water that crossed the boundary. Oh, I'm so sorry. Oh wait, no, I do. It says I do have let's turn that one off. It says I do have a time. Oh no, I don't think I have a time. It should just be a maximum depth. Yeah, it's just a maximum depth. But yeah, so you're not going to get I didn't run the time dependent one on this one or this one. I'm sorry about that. So you're not going to get that. This thing is not going to work on these two. And then you'll see here, though, that you should be able to see here that you have the water is kind of moving to the downstream domain. And again, we'll copy that style and paste it here. And unfortunately, because I didn't get I'm going to have to pull that 1D. I'm going to have to pull that 1D channel in anyway, because I didn't get the time variable data for this. So that means I didn't get, when I don't get my time variable data, that means I don't have the channel depths in the mapping on the southwest and southeast. So that's my fault. So maybe what I can do is I can bring in the channel and see how that works. I don't really, the 1D, let's get southwest. I'm going to go ahead and click add. But this time we'll just take the 1D mesh and click add and click close. And then again, let's just try to use this style. I don't know if this is going to work or not, but let's try it and paste that style. And then this is just your depth. So if you put in a 1D layer over here, you see you get water surface elevation, depth, velocity discharge, limiting, or not limiting fruit, excuse me, this is not limiting fruit, this is calculated fruit, flow area, wetted perimeter, everything that's in high chan.out is in this, and you can map it. Although most of this stuff you don't really map, who cares? But the deal is that the stroke, it's kind of funny because it's just a dot. It's just a line. It's not like a true channel. So you do have to do a little bit of manipulation here. And I believe you have to set this to, let's go ahead and use meters. Why is it meters? We want it to be, I don't know why that's meters, why it can't be map units, but let's see. Let's set this to, I wonder what the approximate width of this channel is. It's approximately 500 feet wide. So let's just see what happens if we do 10. Okay, and I don't think we want to do 500. Oh no, that's about right. Okay, 500. I think this is probably map units, not meters. Let's just try 1,000. So you can see these really aren't, this isn't really a really good 1D representation of a Flow-2D channel. It's really more a, and we can do this in blues. It's really more just to show you, like, you could find if there were any problems with it. So let's set this to blues. And what is that? Why is that? This is bed elevation. We want depth, not bed elevation. Sorry. Let's try that again. We'll do map units. 5. Well, and now this is depth. And of course we don't want, oh, this only gives us 6. Okay, so that's better. Yeah, that's better. And then again, this might have a, this might have like a bit of a time dependency on it. Yeah, it does. You can see it has a bit of a time dependency on it. So you can kind of see the water filling it up. But what it doesn't have is a very good representation of the water in the channel. It's just kind of fake. So the idea of what we're going to do this year is we're going to build this back into the map and kind of make this entire thing like completely functional so that you can see your channel fill with water and, you know, work its way through this system and then, you know, export out or leave the channel at the boundary as well. But so this is what we have for now. It's not super useful. So instead, if you want to see your channel fill and recede and whatnot, you're definitely going to need that time variable data like you have in the north and domain and the full domain. I just didn't set that up on my 2 runs for the south. So the 2D time data is not set up for these 2 runs. But anyway, that's how you do it. That's how you blend a channel or put a channel in and have it cross a domain, in addition to the domain for the the 2D domain exchange as well. And I did this. Now I picked this domain exchange because this road right here kind of blocks quite a bit of the water as it crosses the system. And there's like a natural break here, even for the channel. Like all of this water here was probably stored behind a hydraulic structure and needed to come down here before it could fill into the channel, and everything was in the channel as it crossed this boundary. So that was kind of the idea of choosing this boundary as the boundary marker. Okay, well, I don't have anything else to show you. So if anybody has a question, go ahead and ask your questions and I will go ahead and stop the recording.